Let's go over population growth rate and how it changes over time. So we know that we can calculate population growth rate by simply subtracting death rate from birth rate, right? So natality minus mortality, and that tells us the total number of individuals that are being added to a population at any given point in time. And so for any organism, if we look at this pattern over time, we see that it has a distinctive S-shaped curve. And depending on the organism, the curve might look a little bit different. The S might be kind of low and flat, or maybe kind of tall and skinny, but it's always going to have these four distinct phases of population growth. So it takes a little while for population growth to really kind of kick in at a high rate. And so most populations start with a lag phase where the rate of population increase is relatively low. Could be a short period, could be a long period, just depends on the population. At some point, there's an abrupt transition into exponential growth. And of course, exponential growth means that the rate of increase in population is ever increasing. So we're growing quicker and quicker all of the time. Some organisms can maintain populations in this exponential growth phase for a very long time. Some can maintain populations there indefinitely. But in many cases, populations eventually transition into this deceleration phase where population growth slows down. This curve gets a little bit shallower, and eventually you end up at some state of stable equilibrium, where you're not really increasing, equilibrium. Population's not increasing too much, it's not decreasing too much. It's basically staying at some stable number. And that number, which is different for every population, is known as carrying capacity. Carrying capacity is determined by the limiting factors that are impacting a population. And so as limiting factors change, the carrying capacity of a population can actually increase or in some cases decrease.